Hello students, we'll discuss about chapter 2 in IoT. Okay, so the chapter name is Networks, Fog and Cloud Computing. So first thing about the basic things about the network. Different types of networks are there, right? LAN, WAN, MAN, PAN, so many. Okay, LAN means local area network. So it spans a small geographical area. Okay, inside a room, inside an office where we are connecting some end devices means LAN. It's a high-speed network and it is being controlled by a single administrator. Okay. PAN means personal area network. So it's a type of network for a particular person. Like I'm going to connect my laptop, my Wi-Fi mouse, my Wi-Fi wireless keyboard, like all the gadgets you are connecting to a laptop. We have a small wireless network that is PAN, personal area network, and network which is designed for a personal person. Okay. It's also used in IoT. Okay, so sensors and all connected. No? And so WAN wide area network, we are going to connect two different LANs and two different area. For a wide area, it's WAN. Okay, so it's actually a low speed network because we are going to connect different LANs. They have different providers, so the speed will be less. Okay, LANs connect machines in a factory plant and office. Okay, but WAN is to create low power wide area networks. Okay, so in IoT also we can connect all these devices. Okay, so WAN used. Okay, so this one different net LAN, one LAN connected to another LAN by using internet or another network. Okay, WAN or another type of WAN is internet. Okay, it is in China. This one is say America. Two different LANs connected by using a WAN or internet. Okay, then how these devices are connected? Now we need media, either wired media like copper, fiber optic, or wireless. Okay, wired like copper and fiber optic. Copper is the older one. It data transmits in electrical signals very slow. Fiber optics means they transmit data in the form of light, very faster. Wireless means by using wireless technology they are communicating. Okay, Wi-Fi you are connected, right? So there is first thing network device means devices that can be connected to each other through a network. Okay, my mobile phone is a network device. That means I can connect my mobile phone to another device. I can send message, everything. It's network device. Okay, end device means a device which is either a source or destination of a message transmitted over network. Okay, either I can my mobile phone is a end device. Okay, I can send messages. Okay, server is another end device. You can receive messages. Okay, intermediate device means the devices which connect end devices, say router or say switch or hub or wireless access point, wireless router. All these are intermediate device. Okay. Network address are used to identify the device. Example, we have IP address. Okay, IP address are used to identify a particular device. MAC address also identify a device. Okay, physical channel, how the data are being transferred or travel from source to destination. We need physical channels. Okay, we have network medias like I told you know copper, wired, wireless. Okay, see here this is a topology where all the end device, no IoT end device. Okay, so see here, washing machine, fridge, car, light, all these things are end devices, IoT end device. Okay, they can be connected to other end devices. Okay, through network, through wired or wireless network. Okay, that's what network usage. Okay, network protocols. So protocols are actually rules for communication. So two important protocols are there: Ethernet and IP. Ethernet means the rules which makes the communication between local devices in LAN. IP is a protocol which enable communication between remote devices. Okay, two different network devices. Okay, so they have to be connected by IP. Routing means as you study in the routing switching course. No, route the packet, so direct the packet from one network to another. So how do we route the packet from source to destination? We need routing. Routing actually we are forwarding the packets. Okay, so routers will do that purpose. Okay, layer 3 device like router will do routing. There are different types of routing protocols, static and dynamic. Okay, even layer 3 switch also perform routing by adding a command IP enable routing. Okay, IP routing will enable that routing portion. Then in small office, home office, okay, there we use a single router. Okay, in our home we have a single router. A single router will be used to connect to the internet. Okay, all the devices at home, your mobile phone, your laptop, your desktop, your tab, everything will be connected to internet via this router. Okay, then this router will be the default gateway for all these devices. Okay? Default gateway. To move out of your network, we need to enter the gateway address. Okay, that will be the router address will be the gateway address. Okay, that's what small office home office. Okay, it's suitable for a small office network or a small home network. Okay, single router is enough. That will be the gateway. Then so first two pages about what is network, different types of networks. Okay, here I can ask you what is LAN, what is WAN, what is which one PAN, like that. Here I may ask you what is network device, what is end device, what is intermediate device, what are the different types of medias available, wired and wireless. Wired we have copper and fiber optic. Copper uses electric signals, it's slow. Fiber uses light information, it's very fast. Wireless, different types of Wi-Fi techniques are there. Then we have different two different network protocols for Ethernet and IP. Ethernet means connecting computing devices in LAN. IP means between remote devices. So routing, route the packet or direct the packet from one device to another device or one network to another network. So in Soho we have only single router. That will be the gateway. Okay, that's what coming under the first two slides. Go for the third one onwards, comparing different wireless technology. Okay, I have gone through. I just put many Wi-Fi technologies like wireless technologies like Wi-Fi, then 4G, 5G, 2G, 3G, then LoRa, WAN. Okay, low radiation. Okay, low range wired network, then NB-IoT, Bluetooth, Zigbee. I discussed about many Wi-Fi network or many wireless technologies. Okay, main thing you have to focus is data transfer rate. Okay, just I will type here what are the things you have to focus in this wireless technologies. Okay, just I'll mark here and write here data transfer. Okay, what is the data transfer of each data transfer, how much data they will transfer per minute or per second. Okay, then operating frequency, what is the operating frequency of that particular wi-fi or wireless technology, operating frequency. Then what about the packet size? Okay, what is the packet size of that particular technology? Then what is the encryption method used or encryption key used? Okay, encryption method or algorithm and key. What is the key size? Then range of transmission. If you're using a particular wireless communication, the range of transmission is very important. Okay, so range of transmission, all these things. Okay, we are going to discuss about each wireless technologies features like data transmission rate, data transfer rate, operating frequency, packet size, encryption method, encryption key, range transmission, everything we'll discuss for each and every wireless technology. First one, Wi-Fi. So because of Wi-Fi, now the wireless connectivity is now growing. Okay, anybody, now all the devices now have Wi-Fi connectivity. Now there is no mobile phone without Wi-Fi adapter. Without Wi-Fi adapter, we cannot connect the Wi-Fi. That's why. So many protocols are there. So for IoT, we use Zigbee, Bluetooth, 4G, 5G, LoRa, WAN, yani low range wide area network. Okay, so different ranges of protocols for different ranges. Okay, short, medium, and wide. The picture also shows. Okay, then low power wide area network is used to support long range communication for low bitrate device like sensors, actuators, controllers. So for communicating sensor data, actuator controllers, no, we need low power wide area network. Okay, then go for the next one, Zigbee, another wireless technology, low energy, low power, low data rate wireless protocol for creating personal area network and for connecting your wireless devices for personal purpose. We go for this Zigbee. The IEEE 802.15.4 will be that standard we use. Used for home automation, automating home, no, whatever device at home we are going to automate, automatically operate that. We need a Zigbee network. The devices will talk to each other, okay? By using Zigbee network and medical device collection, okay? I want to get the data from a sensor connected to my body parts, okay? For that I can use Zigbee, okay? Then the data transfer rate is 250 kilobits per second. Then they use as an application profile identification. Okay, for identifying this application, we need a application profile number. Okay, then Zigbee version 1.2 has some serious security vulnerabilities, weakness. Okay, that because we are making it easy for the user to add to a Zigbee device to network. Okay, whenever you're making easy for a device to be added to Zigbee network, there will be some security flaws will happen. Okay, And the range of devices we can connect to Zigbee maximum 300 meter. And they use 128-bit AES encryption, advanced encryption standard algorithm. Okay, for encryption, secret data secrecy. The key size is 128B, and the battery life of Zigbee. Okay, it can be operated for many years because we use a power saving feature called sleep mode. Whenever you are not using that device, no, when you are not connecting any device, no, we can make it in sleep mode so that you can save the battery power. Okay, so it's inexpensive because I'm going to use only one battery or few batteries for years. Okay, and the operating frequency 2.4 gigahertz. The packet size is 128 bytes. So remember this packet size, then frequency, then encryption. Okay, 1 minute. So that was about, okay. So how much is the packet size? 128 bytes, frequency 2.4 gigahertz. What is the encryption algorithm? AES encryption algorithm. What is the key size? 128 bit. Then like that, okay. You want to the data transfer rate is 250 kilobits per second. Okay, remember these things. Now next is Bluetooth. Okay, that's used for short distance in PAN and personal area network. Okay, so all the mobile devices and accessories. No, all the mobile phones are supporting. No, even from the beginning also they support Bluetooth. Okay, the default standard for audio between mobile devices. Okay, so for audio. Okay, for mobile devices, the default standard for audio is Bluetooth. No, we have like Bluetooth speakers. No, so Bluetooth speaker and that this one how they are communicating. We have Bluetooth connections. Okay, then the frequency of Bluetooth low energy. Okay, so this is used in healthcare, fitness, and beacons. Okay, so we have that which one Fit Pro and all. No, so those devices, so they communicate via Bluetooth. Okay, the frequency is 2.4 gigahertz, and they use AES CM encryption algorithm. The packet size is 29. Okay, and the day has a very fast connection rate. Okay, so it will be connected very millisecond. Okay, then it can have the data transfer rate to maximum 2 megabits per second. Okay, data transfer rate, and the range is 1 to 100 meters. Okay, and they also operate in sleep mode so that we can save the battery life. Then there is beacons. Beacons means no, there will be some buildings or coffee shops or some light posts. There we can provide some beacons and some offers. Example, this particular building is providing some offers through the beacons. No, this particular thing we can give alert to the clients. Okay, to avail that services. Okay, so you can click this YouTube link and you can see how this beacons are working. Okay, you want to install that particular application whenever you take a mobile phone and whenever you go through that particular area, that particular shop will give you offers, beacons. Okay, you can check this video. Then LoRaWAN, yani low range wide area network. Okay, it's another wireless technology which provides wireless WAN connection to power constrained device. Okay, there are some devices that have power issues. Okay, so they have some constraints. Okay, so for them, this technology is best one. So it's like IoT based devices. Okay, it's used for IoT device and it has secure bidirectional communication. Okay, two-way communication and the data will be secure. Mobility and localization service. Mobility means that you can keep on moving, and localization means you can track and monitor the devices via the sensors. Okay, by using IoT sensors, you can track and monitor the devices. Okay, status of devices. Okay, now we can keep a RFID sensor so that it's on a particular truck or something, and we can track it how far it reached like that. Okay, like GPS sensor. Now architecture is like as an extended star topology. Okay, star. Okay, so star topology where gateway will be there, which will relay the message between end device and the central network. So there will be a backup server in the backend. Okay, end device will be connected to this one, and through the gateway they are sending message. Okay, router will be the gateway. Okay, and the data transfer rate, that's important. Okay, data transfer rate is 0.3 kbps to 50 kbps, and it uses a multi-layer encryption scheme, and we have packet size to 256 bytes, and the data transfer rates mentioned here. So 250 bits per second to 22 kilobits per second. 128-bit AES key which one? Advanced encryption standard keys is 128 users. Okay, battery life is 10 years. So here We can check what is data transfer rate, what is operating frequency, what is packet size, what is encryption. Okay, next is 4G, 5G. After LoRaWAN, then go for 4G, 5G. 5G, we even hear about 60, 70. Okay, so these are fourth generation, fifth generation, okay, wireless networks. So cellular based data network, okay. So is for large geographical area, high mobility bandwidth of 4G is 100 Mbps. Then we can take the mobile phone or laptop, we connect to 4G network, and we can have that data transfer rate 100 Mbps. Okay, low mobility and the people who are pedestrians walking or maybe stationary, they are sitting in front of a place, park or somewhere and using the mobile phone with 4G connectivity, the speed will be 1 gigabits per second. Once you are moving, the speed will go down. But once you are sitting in a stationary place, the speed will be the data transfer rate will be 1 gigabits per second. Okay, the frequency of 4G is 6 gigahertz. Okay, frequency. Then 4G supports voice, IP telephony, mobile data access, video calling, gaming, cloud computing, HDTV, mobile utility, everything. Okay, you can watch this one Netflix with high definition HD or Amazon Prime, then voice over IP, then mobile internet access, video calling, everything you can do in 4G. LTE and WiMAX are two popular 4G systems. Okay, so LTE, long-term evolution, they contains narrowband IoT, another technology for IoT. Okay, for connecting devices, IoT device in the narrowband frequency. Then next generation mobile network is 5G. The data transfer is 20 times. This is 1 Gbps means here it will be 20 Gbps. Okay, the frequency is up to 95 gigahertz. What about the frequency here? 6 gigahertz. So again, it's almost 12 times or like that, 15 times. Sorry, 15 to 6 times. The frequency will be 95 gigahertz. Okay, I put red color. Then the encryption they use 256-bit encryption used by 5G. 4G uses 128-bit encryption. Okay, so you can highlight this one. Then the algorithm used is Advanced Encryption Standard (AES) algorithm. Okay, so remember what is 4G, what is 5G, what is the frequency of 4G, what is the frequency of 5G, data transfer rate of 5G and 4G, everything mentioned here. Okay, after that LPWAN, low power wide area network, is another type of wireless communication network for long range communication at low bit rate between IoT devices, okay, sensors on a battery. So between IoT devices, if you want to go for that long range communication, low data transfer, you go for LPWAN. Okay, so the operating range is 40 kilometers. The devices can be far away of 40 kilometers. Frequency is 862 to 928 megahertz. Okay, and the data range 0.3 kilometers to 50 kilobits per channel. Okay, so battery life is almost 1 year. So here also we mentioned the frequency, the data transfer rate, the kilometer, yani that range of communication or range of transmission, battery life, everything is given here. Okay, all these things are coming under wireless technologies. Then IoT protocols. Protocols are actually rules for communication. Okay, that protocols are used for rules. Okay, so here IoT device also have some protocols. Okay, so IoT device contain embedded device. Any they have hardware, they have software, they have internet. Example smartwatch. They have hardware, they have software and internet. Okay, so they are to be designed to work in suboptimal or not so best conditions. Okay, sometimes some sensors are connected to outdoor, maybe so much of signal, noise, distraction. Some are connected to human body. Okay, they have to be work in any condition. That's why suboptimal condition, and they need specialized protocols to function with low power and limited connectivity. Maybe they are having low power. Okay, they maybe work with limited internet connectivity, but still we need specialized protocols so that we can extract the required data from those sensors. Okay, that's why we need different protocols for IoT. So different types of IoT protocols are for infrastructure to give IPv4 and IPv6 address. We have IPv4, IPv6, RPL, then low PAN. Then identification, we have IPv6 and URI, Universal Resource Identification. Communication or transfer protocol, we have Bluetooth, Wi-Fi, LPWAN to connect all devices. Okay, the first two are just assigning IP address and all. Third one is communication. How the devices will communicate with each other. We need Bluetooth, Wi-Fi, or LPWAN. Discovery, we have DNS, physical web. Okay, DNS protocol for identifying the device. Just we give that name. We have to convert that IP like that IP to name like that. Okay, Data protocol we have MQTT and COP. Okay, we'll discuss about MQTT. I think we already discussed in chapter one. The same will here and here. Okay, same will discuss MQTT and COP. Okay. After that, what is MQTT? What is COAP? COAP means Constrained Application Protocol. Okay. So constraint means controlled, restricted, or limited environment. Okay. So we have to connect the devices with the limited power, limited connectivity. All these devices to upload data. Okay. With low bandwidth and low availability, we want to connect this device network by using HOP protocol. Okay. See how low power compute constrained device can function IoT. So simple devices to join IoT via constrained networks, okay, of low availability and low bandwidth. Okay, we are going to connect these devices with networks of low availability and low bandwidth, like HTTP, and we use the protocol. We use the function like HTTP get put post like that. Okay. MQTT means message queuing telemetry transport. Okay, so telemetry means the technology to measure and collect data from remote locations and transmit to receiving systems for monitoring. Okay, so here it it allows IoT device to publish data about a specific topic to server that operate as a MQTT message broker. Okay, so we are going to upload some data about publish a data about a specific topic to a server. Example, we are going to upload some message in Facebook Messenger, Amazon Web Service, Microsoft Azure, OpenStack. So these are all examples of MQTT applications. Okay, so telemetry is used for mainly telemetry. Actually, for telemetry means technologies that measure and collect data for remote locations. So remotely from device, we have to collect some data from remote locations, transmit to a receiving system for you have to monitor the data. Okay, this is MQTT and COAP. Go through that at least that highlighted one. Okay, where we will apply this. Then last one, how do we secure the network? We have an architecture like this. Okay, first one, authenticate. Every device should have some username and password. Authenticate the device. After the authorization, what are the information we can access? Then we have a policy. Transport the data of the device securely. Okay, and we have secure analytics. Okay, visibility and control. Any what type of data should be visible or available, and what are the data we can monitor or control? Depends upon each one's which one. We have some priorities or we have some privileges. Based on that, we can view the data, monitor them, control them. Okay, so authentication in the sense, no example, traceable signatures. Okay, every device will be having some RFID or encrypted key or password so that we can make the data confidential. Okay, by using a identification identifier or password, then what type of data, how much data you can access, what type of data you can you have the permission to access, that is authorization. Network enforcement policy, I told you, how do we transport the data securely? Okay, all this is coming under network security, securing the network. Okay, okay, now we go for 2.2 fog and cloud computing. Okay, these are two computing models. So, what is cloud computing model? Okay, so all the data from the devices, the end devices, no, all are being uploaded to a server in internet. Okay, a data center. Okay, so it is in internet. It's this is not in our college premise or our office premise. Okay, the data will be uploaded to a server in internet. Okay, and on demand access. So on demand access to resource. Okay, whenever you want you can access it. Like I want to use Photoshop, I don't want to download the Photoshop software, install nothing. I have a cloud account now. Once I have a cloud account, I can take the Photoshop. I can just pay the money for how much time I use for the use the resource. Okay, then I will pay the money and I will use it. Once I finish the usage, I'll disconnect. Okay, this is what on demand access to resource, that's cloud computing. Okay, the resource will be made available quickly, so we can easily access the resources. Okay, cloud providers use data centers for their services. Okay, so here there will be some data centers. Okay, the servers will be in some other location. Okay, we can whatever service we can have, we can upload in the data center, we can available the data center so that we can pay the money and we can use the resources from data center. Okay, Amazon is a cloud provider. Okay, Google is a cloud provider. All these are cloud computing providers. Okay, pay as you go for computing and storage expenses. Okay, so yeah, I don't want to pay. and download the software, install it in your computer. Just how much you have used, pay for that, and you can leave that. Okay, that's what. No need. There's no permanent attachment. Okay, just pay for the usage and just leave the site. Okay, enables access to data and applications anywhere, anytime. So, like earlier when I was no, whenever we were working here, no, this is 2017, like that time, no. Whenever you are going home, you have to take all the data in flash drive or pen drive or USB. And if you want to work at home, you can even in India also. I'll go to India. I'll take all the data in flash and I'll go and work from India. But now, no need for you to take the data copy. Just upload the data into cloud. We have OneDrive, no. Upload the data into OneDrive. Okay, then whatever data you want to do, just go to India, wherever, Pakistan, Bangladesh, wherever you go, open your cloud account or OneDrive account, then download the data and start working. No need for you to permanently carry the data in flash drive or USB. No need. Okay, anywhere, anytime you can access it. Then reduce the cost of equipment. Okay, so the cost of equipment, personal training, everything is now reduced. So cloud offers three services: infrastructure as a service, platform and mobile platform as a service, then software as a service. Okay, they will have they will provide different service. They will sometimes they will offer software as a service. They can provide say Photoshop software available in cloud platform. Then the OS also will be provided. Then hardware infrastructures also will be given as a cloud. Okay, cloud services. See, the customers have access to shared pool of configurable computing resources. Okay, so there will be so many resources here that customers can access it anytime. It will be available on internet. Okay, you can have just have an account and you can easily access it. Okay, so data processing and storage done in cloud instead of IoT device. Nowadays, now that data whatever you process in the IoT devices, no, they will not be stored in the locally. They will be stored in the cloud internet server. Okay, and data and resource will be always available to any device system and device has internet connectivity. So whenever you want to access the data, only condition is you should have internet connectivity, then you can access the cloud server. Okay. Then, but problem is they have so much of security issue. So we have to ensure the customer data is kept safe and secure. Okay. So if your personal data is being uploaded in the cloud, means if someone is breaking or hacking that particular server, only data will be insecure. Okay, so examples of cloud service, but nowadays not like that. Every cloud service will have this one security, so that data will become secret. But still, it's an issue. Okay, so if someone hacked that particular cloud account or the cloud service, what happened now? The data will be available freely for this. Okay. Examples of cloud service: Amazon Web Service, AWS, IFTTT, Zapier, Build.io, WebEx Teams, Google Cloud, Microsoft Azure. All these examples for cloud service. Okay. See this picture. See here, wherever I applied fog computing, where I applied cloud computing, with fog computing. I'm just using this in the company. Okay, the data will be processed by the fog. What is fog computing? I'll tell you later. Okay. Then here also fog computing. Saying this is a fire. Uh, which one? Department office. Okay. Cloud computing means say even that. See, it is a office means no, whenever fire occurs, okay, we need the processing immediately, so we go for computing, okay. But there are some cloud computing where the data centers, the servers will be in internet. So this is cloud computing. This one is a airport. There I have some processing. So I want to process some data from the sensor faster way means for computing. Okay, what is for computing? Tell you next one. For computing means it's computing closer to network edge. Yani uh, computing will be done in the router itself. Okay, it will not take the data to the cloud. The computing will be done in the server, the router itself. Okay, edge devices will run locally and immediate decisions. Okay, so edge devices, the end devices will be connected to the routers, and the processing is done in the router, and the data and decisions will be taken by the router itself. Okay. For example, we are going to do a traffic project. Okay, so the traffic project means so immediately we have to alert, we have to whatever status is there, we have to immediately process the data and give the output to the users. Now, for those things, cloud is very risky one because sometimes the internet connection to the cloud will be down. Maybe cloud takes a lot of time, but here work means everything is connected to our own networks or it is done by the router, so there is no need of worrying about the internet issue. Okay, reduces data burden as raw data is not sent down network. Examples here, sometimes no, whatever data you have in cloud means you are simply uploading data in the cloud. Sometimes no, it's not safe to upload the data. So which one? Fork means data will not be uploaded in the net. Data will be available in the router itself. So that we can easily manage. Okay. Enhance security, keeping sensitive data from being transferred beyond the edge. Okay. So here the security also improved by not transferring the data outside the network. The data will be transferred only to the router or the gateway. Okay. Then fog monitors, where we will apply this is real-time applications like locking a door. I want to lock a door. Somebody entered the room. Okay, motion sensor detected. Then I will lock the door. That don't know. We don't want to send this data to the cloud. We have just a router. They will manage. Okay, so that easy processing. Changing settings of a device, applying brakes on a train. Say one day one thing I told you. Okay, so train is coming faster and train is going to hit an object. So that time I don't have the time to upload the data, sensor data, pollution sensor data to cloud. I have to do the processing immediately. That instant itself. That time what we need, the router will take all the data. They will process. Okay, zooming into the video camera. Then machine to machine communication, machine to people interaction. This happens in fog computing model. And by 2008, actually we are already in 2024, okay? By 2018, 40% of IoT connected data will be processed in the phone, okay? Because I need faster processing. Big data. Nowadays, now the data is being growing at a faster rate. Now, number of sensors, number of devices connected to the internet will be huge, okay? So what happened? Many devices will be producing so much of data. So the data is now growing in many volumes, okay. So here we need the customer requires anytime anywhere on demand data, okay. So smart grid, Vande Bharat, connect train, cars, everyone needs data. So problem is, if whenever the data we are collecting is more, the problem will be there to store the data, analyze the data and secure the data so that we can use it for next process, okay. So to handle, see, we have a definition for big data. The data is so vast and complex, difficult to store, process, analyze using traditional storage and analytics tech. Okay. So huge amount of data. It's difficult for you to process the data, store the data, and analyze in the normal way. So what we have, three dimensions in big data: volume, velocity, variety. Volume means amount of data being transported and stored. Okay, how much data you are transporting and storing. Velocity, the speed at which, the rate at which data is generated. Okay, in some sensors, you remember that when you do that heartbeat sensor, no, every second they are giving data. So what we do, that's why after taking data one time, what we do, we give a delay of 1000 or 2000. That means the sensor will take 2 seconds delay, then only they will read the next value. Otherwise, what happen, every second, every quarter of a second, they read the value, the sensor will be now damaged. Okay, that's why we have to give some time, which one? Delay between the sensor reading. Variety, different types of data, okay, for processing analysis. Okay, we can take, by using IoT, we can take different types of data. Okay, and Apache Spark, Apache Hive, Apache Storm, MongoDB, all these are examples for open source projects with big data. Okay, then data storage. How do we store this data? So we need to store the data for a particular amount of time, okay. So we need to store the data in a particular place, and we need to encrypt those data, make the data inside will be secret so that no others can read the data. Sometimes no, the even the hard drive itself have encryption features, so the day when you go for that encryption, the hard disk data will be encrypted, okay. You cannot decrypt it until you know that key, okay. Now we have self-encrypting flash memory. So the flash memory itself, we have self-encrypting. So whatever data you have in the flash drive, it will be encrypted, secret form, so no one can access it, okay. Then if data is not properly secured through encryption, it can be intercepted, captured, manipulated. Mr. Why you secure the data, why we encrypt it? Because anybody can intercept, change the data, capture it and damage the data. There are so many encryption algorithms which do this encryption, okay, or say make the data secret. So, and again, we need to protect its firmware, the IoT device firmware also we need to protect. Firmware means a part of OS, okay? And the data it transfers, you have to secure the data as well as the firmware. So, whenever the IoT devices are running older versions, okay, for the latest version, the firmware will be and protocols will be updated, okay? So, always run the latest versions of all the softwares, firmwares, everything, okay? Then server, cloud endpoints, internet device should be also be secured. So what are things you should secure? Server, cloud endpoint, okay, and intermediate device, router, switch, hub, everything should be encrypted or secured. This is what coming under chapter 2. Okay, please go through the chapter, easy chapter.